let's work with an example to see how one would go about solving for the contract curve. So let's take the preferences where Rob and Friday both have these Cobb-Douglas preferences. So Rob's utility from consuming AR apples and BR bananas is just the product of the two. And similarly for Friday, the utility from consuming AF apples and BF bananas is just the product of the two. Right? So the definition of the contract curve is that it's a set of all pairs of bundles, right? So of all allocations that are Pareto efficient. So what we want to do is we want to find the set of all such allocations that satisfy the property that the marginal rates of substitution are equal. Okay, so what do we know about an allocation that's Pareto efficient? Well, like I said, the resource constraints have to be satisfied. Right? So everything has to be consumed. So what are the resource constraints? Well, if Rob consumes AR apples and Friday consumes AF apples, the total number of apples we have is 80. So we should be allocating all of the apples. We shouldn't be throwing any away. So we should be allocating 80 apples. We should be splitting the 80 apples between Rob and Friday. Similarly, we should be splitting the 50 bananas between Rob and Friday. If we have these, what we can then do is to solve for Friday's apples in terms of how many apples Rob gets. Similarly, we can solve for Friday's consumption of bananas in terms of the number of bananas Rob gets. Next, we know, like I said earlier, the marginal rate of substitution needs to be equal. Right? We've got these nice preferences here. They're Cobb-Douglas. So all we need to check is that the marginal rates of substitution are equal. So given the preferences we have, the marginal rate of substitution is just minus BR over AR for Rob, minus BF over AF for Friday. The negative signs cancel out. So we just have this nice equation that BR over AR equals BF over AF. Okay, so what we're going to do is we're just going to substitute in these values for AF and BF into here, right? So BF is 50 minus BR, and AF is 80 minus AR. So we've got this equation. Okay, so what we can do next is to solve for the number of bananas that Rob should consume in terms of the number of apples he consumes. So what we'll do is we'll first cross multiply these two fractions. So BR times 80 minus AR has to equal AR times 50 minus BR. So expand that out. 80 times BR minus AR times BR has to equal 50 times AR minus AR times BR. Well, these guys cancel out. So we get BR, so dividing through by 80, BR is 5 over 8 times AR. This tells us what the contract curve is. All right, we could just go back to our Edgeworth box and just plot a line through all the allocations where BR equals 5/8 of AR. And that would tell us what the contract curve was. So any point on this line would be Pareto efficient. So examples of points on this line are where AR is 0. So if we give no apples to Rob, well, Pareto efficiency says, well, you shouldn't give any bananas to Rob as well. Or if you give all the apples to Rob, well, then how many bananas should you be giving him? Well, you should be giving him, oh, sorry, the other way around. If you give all the apples to Rob, which is 80 of them, how many bananas should you be giving him? Well, you should give him all of them, which is 50. Or if you just gave him 8 apples, well, you should give him 5 bananas, and so forth. Right? We could find a whole bunch of allocations that are Pareto efficient. So, of course, this is just telling us what Rob gets, but the resource constraint then tells us what Friday gets. Right? Calculating Friday's bundle, we just use the fact that Friday just gets the leftover apples and the leftover bananas. If Rob gets AR apples, Friday just gets 80 minus AR, which is the leftover ones. Similarly, if Rob gets BR bananas, Friday just gets the leftover bananas, which is 50 minus that. So that's how we find all of the allocations that are Pareto efficient.